Modern language models are ravenous. They devour text and labeled examples faster than humans can possibly produce them. And the high-quality stuff is expensive or private or simply running out. So researchers asked a bold question. What if the models could generate their own training data? That is synthetic data, and it now quietly powers a huge share of how today's models are trained and aligned. But feeding a model on its own kind is a double-edged move, and understanding why is the whole story. Let's dig in. First, let's see what synthetic data is really competing with. Real collected data is the gold standard. Text written by humans, labels annotated by experts. It reflects the actual world and carries genuine signal. The trouble is supply. High-quality human data is slow to gather, expensive to label, often locked behind privacy walls, and for many niche domains it barely exists at all. And every new frontier model only makes the appetite for fresh, high-quality data larger, so the shortage keeps getting worse. Synthetic data flips the economics. Instead of collecting from the world, you have a capable model generate the examples for you, cheaply and on demand, in whatever shape you need. You can produce oceans of it overnight, target exactly the cases you're short on, and never touch a single piece of private information. Need 1,000,000 math problems or dialogues in a rare language? A capable model can simply write them for you. So how do you actually turn a model into a data factory? Watch the loop. It starts with generation. You prompt a strong model to produce the examples you want, instruction and response pairs, preference comparisons, worked reasoning steps, whatever the target task needs. Techniques like self-instruct can bootstrap a huge, varied set from just a handful of seed examples. That single trick multiplies a tiny bit of human effort into an enormous training set. Next comes the critical step, filtering. Raw model output contains errors, hallucinations, and junk, so you verify and cure it, keeping the good examples and throwing the rest away. This quality gate is what separates useful synthetic data from a pile of confident nonsense. Skip it, and you're just amplifying the teacher's mistakes into the next model. Then you train. The curated synthetic examples become the training set for another model, often a smaller student learning from a stronger teacher. Alpaca famously did this, tuning a modest model on instructions generated by a much larger one. The student inherits the teacher's behavior at a fraction of the collection cost. Finally, you keep it grounded. Rather than training on synthetic data alone, you usually blend it with real data so the model stays anchored to reality and doesn't spiral off into its own artifacts. Generate, filter, train, mix, that's the whole loop. Strip it down, and 3 ideas capture synthetic data. At its core, this is data made by models rather than gathered from the world. A capable model writes the examples, the labels, the comparisons, standing in for the human annotators and real-world collection that used to be the only option. Whole datasets can now be conjured where almost none existed before. Its superpower is economics. Synthetic data is cheap, fast, endlessly scalable, controllable, and privacy-preserving. You can conjure exactly the distribution you want in volume on demand, which is why it now underpins a large and growing share of how models are trained and aligned. But it is double-edged. Without careful filtering, model errors and hallucinations teach the next model wrong things, and training models on model output risks model collapse, a feedback loop where successive generations lose diversity and drift from reality. It must be verified, filtered, and mixed with real data. All right, let's lock in the essentials. Synthetic data is training data generated by models instead of collected from the real world. It is cheap, fast, scalable, and privacy-preserving, so it now underpins much of how models are trained and aligned. From instruction tuning to RLAIF preferences, it fills gaps where real, high-quality data is scarce, costly, or private. But it demands filtering and a mix of real data, or errors compound and models collapse. If you enjoy AI explained this plainly, come explore more with us over at standarity.com. See you inside.